For 1.2, we're going to actually do some algebra things. This should all be things that you've done before, but we're just making sure you remember. We're going to make sure you know some of the correct vocabulary. So the first one is variable. Y'all know what a variable is?
Yeah.
Letter, yeah, something like that. Okay, it's a symbol that's usually a letter.
Symbol, usually a letter.
Oh, that's rough looking. Usually a letter that represents one or more numbers. An example of a variable is A. Usually we use lowercase. Sometimes we use uppercase, but most of the time it's lowercase.
What's the difference? No.
Nothing really, except when you get into more complicated things, like sometimes, like we talked about matrices in chapter 4, those are like they're like groups of numbers, and so we'll use like a capital A to represent like a certain set of numbers. So they're kind of bigger things, so we use the bigger letters. So just most of the time we use lowercase. All right, from variable, we go to algebraic expression / variable expression, okay? We use either word. Most of the time I'll say algebraic expression. That is an expression which contains one or more variables.
Expression that contains one or more.
You weren't really good for you writing on a freaking iPad.
Thank
Those
you.
are so hard to write on.
They are. Having a good stylus makes a big difference. Because sometimes if I lose this one, I'll use my bad stylus and it's much harder. Okay, an example of an algebraic expression would be like 2a plus 3. It's just an example, right? Or just 2a could be an expression. Or just a. Or something that's really, really long. Okay.
Not just 3.
Yeah, I could just, well, it doesn't have variable. You're right. It's an expression, but not an algebraic expression. All right. Then evaluate. That's what we do with these expressions, or at least what we're going to do today. When something says evaluate, that means we're going to plug values in for the variables and kind of simplify from there. So we're going to substitute. Ooh, that one got a little rough. Or the less official way to say it, plug in numbers for, yeah, that's fine, for the variables in an expression and follow order of operations. Yep, that's what I was about to ask. PEMDAS. Do y'all everybody remember PEMDAS? Anybody not remember? What's the P?
Please excuse.
Parentheses, the math thing. Parentheses, and then exponents, multiply, divide, add, subtract. Okay, I think we got it. So let's just do like a really quick example of this. So let's say it says evaluate when A equals 4 for our expression we said, 2A plus 3. So we're going to put 4 in for A. So 2 times 4 plus 3. What do we need to handle first? Parentheses. Okay, is there anything to like simplify in the middle of the parentheses? Between them? It's just 4, right? But then we got to multiply outside, so that's 8 plus 3, so the last thing we do is add, we get 11. Rough.
That is what's up.
Let's practice. So we've got this expression, a minus 2b plus ab, for a equals 3 and b equals -1. We need to evaluate. So everywhere there's an a, we're going to plug in 3. Everywhere there's a b, we're plugging in -1. So we've got 3 minus 2 times -1 plus 3 times -1. I'm really going step by step by step on this. If you remember this stuff and you want to write how you're thinking or whatever, that's fine. I'm going to write it out step by step. Okay, so first thing we take care of is parentheses, right? Do we need to do anything with the 3? No, so it just stays how it is. Okay, the next one, what do we do here? Multiply, what do we end up with? Plus 2. Okay, the last part, what do we end up with? Minus 3. Okay, because we had a negative in there. Okay, so what's 3 plus 2? Minus 3.
That's 2.
That's 2.
That's our answer.
2 is our answer. Alright, next one. Down here, we've got 2 expressions. Now we have x and y. So let's do the first one first. X plus y divided by x. We've got 4 to go in for x, -2 to go in for y. So I'm going to put 4 plus -2 divided by 4. So which part do we have to handle first? -2 divided by 4. I'm going to write it out as a fraction because that helps me. So minus 2 divided by 4. Can we reduce that?
Definitely want to have. And that'd be -2, right?
1 over 2. Okay, can we subtract those the way they are?
I don't know right now.
No, we need a common denominator. So what do we need to put underneath the 4? A 2, so what does the 4 become? 8 when we multiply 4 times 2. So now we have 8 minus 1 all over 2, because we had our common denominator, so we get 7 over 2.
That's great.
Any questions at all?
No.
Okay. Alright, now the next one. Same values we're plugging in. So we've got 4 plus 2 times 4 divided by -2 minus 2 times -2. What do we need to deal with first? 2 times 4, so that becomes 8, and then we're dividing that by -2. Okay, the 4 stays in front. And then what's going to be at the very end? The -2 times -2
Just about it all.
plus 4. Okay, what's 8 divided by -2?
That'd be about
-4. So 4 minus 4 plus 4 gives us
Whoa.
4.
That is crazy.
So many 4s. Okay, so I accidentally didn't record this, but all we did was plug in the 3 for the x's. The thing to point out, sorry, you'll have to listen to it again. The thing to point out is that the squared only applies to the x. It doesn't apply to the negative. If there were parentheses putting those two together, it would apply to both, but in this case it doesn't. So 3 squared is 9, and then the negative comes down in front. And then the rest is like what we did before, and we get -17. I think y'all should do this one on your own. Okay, try it on your own. We'll check, see if we all get the same thing. So the difference between this one and the one before is that when we... You should interrupt me faster next time. Okay, forgot to record again. So the big difference, y'all are just really going to know this really well. The big difference here is that for C, the squared applies to all of it. So it includes the negative. So -3 times -3 ends up with +9. Over here, the negative was separate from what was being squared. So negative just came down, and then we got 25. We ended up with negative 16. Let's move on to the next. And we have a word problem. Yay, it's everybody's favorite.
No, that's like
The worst thing ever. Okay, the expression negative 0.3y plus 61. Okay, that's like very mathy, so I think that's important. And I kind of mark that. Models the percent of eligible voters who voted in presidential elections from 1960 to 2000. So that's the percent of eligible voters. That's the basics. All right. In the expression y, okay, it's telling us about our variable, represents the number of years since 1960. That's what y is. That's important. Now, what is it telling us to do? Find the approximate percent of eligible voters who voted in 1988. Okay, approximate percent in 1988. So, our first thing we need to do is figure out what y is for us. Like, what does y equal? So, since it's the number of years since 1960, what year are we going for? 88. That's what it told us to find. So we need to say 1988 minus 1960. We need to know how many years surpassed during that. So that was what? 28. Okay. So y equals 28. Now we just do what we've been doing in our examples. We just plug it in. So negative 0.3 times our y, which is 28. Plus 61, handy dandy calculator. What's it going to end up being? 52.6, and then what is that? Like years, inches, what is it? Percent. It's percent. Okay, so that percent represents what? It represents how many eligible voters voted in 1988. Only half of all the people who are eligible to vote voted. Tad bit over, but approximately. All right. All right, let's keep going. We're going to break down our algebraic expressions into different parts. The first part we're going to talk about are the terms. The terms are a number, a variable, or a product of a number and a variable. And I'm going to put an S in parentheses because we can definitely have more than one variable. Okay, that's fine. As long as you know it. So, over here, the terms, we've got two terms. Here's one, and here's the next one. All right? So, basically, the terms are everything that's between the pluses and the minuses. Okay? So, this expression has two terms, 1 and 2. Now, the coefficient is the number part of the term. Okay, so the first coefficient is 7, the second coefficient is 3. So the proper way to say that is numerical factor in a term. Okay, now what can we do with these things? Well, it depends on if they have like terms. Okay, well, do you know what is required for them to be like terms?
They gotta be odds or even positive. They have to be the same variable.
Same variable. Very good, Osmar. Raised to the same power. And power means exponent. Okay, so x squared and x squared, are those like terms? Yes. What about x and x squared?
No.
No. They don't have the same power. So they're not
-1.
like terms.
No.
Huh? Yes, and -1 is fine. Coefficients don't matter in like terms because the negative is part of the coefficient. All right, so we can simplify our algebraic expressions by combining like terms. And when we do that, we're going to add the coefficients. Y'all have done this before, I believe. Tell me if you haven't. So, in this first example, are these like terms? Yes, are they the same variable? K and K? All right, do they have the same power? What is their power? 1, very good. There's an invisible 1 with both of those. Very good. So now we just need to combine their coefficients. So the first coefficient is 3. What's the next one? It's a -1, so 3 minus 1 gives us 2k. Could you have done that without me saying 4 sentences about it? Okay, the next one, which terms are like?
-10z.
All of them?
No.
Well, just 10z and z.
Just the first term and the second term. All right, so if we combine those, what do we get?
-9z -8z².
-9z from the -10 and the positive 1. And then for our -8z squared, it's by itself. Where does it go? Do you know? No. Does it go in front or behind? Actually, it's in front. You put your bigger power first. So the squared basically gives it hierarchy, so it goes first. More power, you're first in line, right? Like Mr. Smiley, he can cut in line in the lunch line. Coach Hudson, he just goes right to the front, doesn't he? Yeah. Okay. There's that one. Now let's do the next one. What do we need to do first to get rid of parentheses? Distribute. Okay, once we distribute, we've got 2m minus 6n. The 6n came from 2 times 3. Are there any like terms? No, the variables don't match, so we're done. Any questions on combining like terms? Any at all? No, not today. Okay. One last problem. Which expression represents the perimeter of the figure at the right? What's perimeter? All the way around. The distance all the way around. So let's just kind of break it down by the different lengths. For 2a minus b over 2, how many of those do we have? 2. Okay, let's see. What about b? How many of those do we have? 3. A, we've got 2, and 2a, there's just one of them. So instead of writing this out as 2a minus b plus 2, plus 2a minus b plus 2, plus b plus, okay, instead of going like that, I'm going to say I've got 2 of 2a minus b over 2. So I'm going to write it as 2 times 2a minus b over 2 plus 3 times b plus 2 times a plus 1 times 2a. I'm just going to write it as 2a. Does that make sense? That we can write it like that? It's a lot less to write down. You guess so? Okay. Yeah, we can combine the 4a together. And we've got our 3b. But this fraction thing, can we simplify this? What can we do?
Distribute first.
We could distribute in, but there's actually something we...
Yeah, because the 2's are divisible.
Right? There's a 2 being multiplied on top and 1 on bottom, so we can
Minus b, so 2a.
cancel.
2b.
Aha, very good. 2a minus b Like that. Hello.
Friend, can I borrow Joseph real quick?
Yeah. Wait, Joseph, he's not in here. He's next period.
Thank you.
Okay. All right. So how many A's do we have total? 6 A. How many B's?
2.
So which one is our answer?
That would be C.
C.
Say.
Any questions? Does that like not make sense the way I did it? Because you can do it more than one way. All right.